Hi students, in this class we are going to study the graphing functions using transformation. Okay, so we are going to discuss all the concepts under this topic, and then after that we are going to do all the problems under exercise 1.4. Okay, so first let us see. The main objective of graphing function is to draw the curve of the function without plotting the points. Okay, so in your previous classes, that is in your 10th class, you will be drawing a graph for the given function. How will you draw the graph? You will get the values of x, you will give some values of x like -2, -1, 0, 1 and 2, and you will calculate the value of y, and then you will plot all those points in the graph sheet and you will draw the graph, right? So this is the proper way of drawing the graph for the given function. Okay, and this graphing transformation helps us to draw the curve of any function without plotting the points. Okay, no need to plot any points, but roughly you can draw the curve of the function by using this graphing transformation. Okay, this is the main objective of this topic. Okay, so now let us see what are the types of transformation that we are having. Okay, so the first type is a reflection. Okay, second one is translation, third one is dilation. So there are three types of transformation. One is reflection, second translation, third one is dilation, and then in the next slide we are going to see one by one. Okay, so first let us see reflection. Okay, so in that reflection what we are doing is the reflection of the graph of a function with respect to a line L is the graph that is symmetric to it with respect to L. Okay, reflection is nothing but symmetric. Okay, symmetric with respect to the line L. Okay, and in another way we can define this reflection, that is, it is the mirror image of the graph. Okay, where line L is the mirror of the reflection. Okay, first word is symmetric with respect to L. Second, the other way of defining the reflection is mirror image of the graph, where the line L is the mirror of the reflection. Okay, so if we can draw the graph diagram, you can draw like this. Here f is the function. Okay, and this f dash is the reflection of f. Okay, and here where L is the mirror of the reflection. Okay, mirror of the reflection. And in the first definition you can say that f and f dash are symmetric with respect to L. Okay, so in this way you can say this reflection. Okay, so f dash is the mirror image of f with respect to the line L. Okay, and the graph y is equal to minus f of x. So if you are having the function y is equal to minus f of x, it will be the reflection of the graph of f about the x-axis. Okay, so we are having three important points and you should remember that. If you are having y is equal to minus f of x, this is the reflection of the graph of f. Okay, f about the x-axis. Okay, about the x-axis. I just changed the color for the important key points. Okay, and you should note it down. Okay, and then next one, the graph y is equal to f of minus x. Okay, if this minus is inside the function, it is the reflection of the graph of f about the y-axis. Clear? Okay, so if the minus is inside the function, then it is the reflection about the axis y-axis. If it is outside, minus f of x, it is about the x-axis. Okay, and then the graph y is equal to f inverse of x is the reflection of the graph of f in y is equal to x. Okay, in y is equal to x. Clear? Okay, so this is all about reflection. And now the next type is translation. Okay, for this translation, okay, a translation of a graph is a vertical or horizontal shift of the graph that produces congruent graphs. Congruent graph means same graph. Okay, same graph. Congruent means same, identical. Okay, you can give words like this. Okay, so translation means it is a vertical or horizontal shift, okay, of the graph that produces congruent graphs, same identical graphs. Okay, so the graph, this is very important. Okay, the graph of y is equal to f of x plus c. Okay, if you are having f of x plus c is inside the function. Okay, so if you are having f of x plus c causes the shift to the left. Okay, it will the graph will shift to the left side. Okay, and y is equal to f of x minus c causes the shift to the right side. Okay, to the right side, and y is equal to f of x plus d. Okay, here the constant d is outside of the function. Okay, f of x plus d, and it causes the shift to the upward. Okay, and if you're having minus d, it causes the shift to the downward. Okay, and this is the important point in translation. Okay, so the shift will be left or right or upward or downward according to these functions. So if you are having y is equal to f of x plus c, the shift will be what? Leftward. And f of x minus c, the shift will be right side. F of x plus d means shift will be towards the upward, and f of x minus d will be downward. Okay, so in this way you can see I have drawn the diagram for you, and the center for this is the always I colored red for the basic function. Okay, so this red color, see, this red color is modulus x. Okay, this is the basic function f of x. Okay, f of x is modulus x. Okay, here this is what? Modulus x minus 1. That means f of x minus 1. Minus 1 is inside the function. Okay, so if it is inside f of x minus 1, so it will come under f of x minus c. It causes shift to the right. Okay, so you just compare red and blue. Red and blue, this blue is identical to red. Okay, and it is shifted to the right side of this modulus x, red color diagram. Are you able to understand this? It is shifted to the right side by 1 unit. Okay, by 1 unit, because you are having the value c as 1. Okay, so for 0 it will be 1, and for this point 1 comma 1, this is 2. Okay, 1 unit, it will shift to 1 unit to the right side. Okay, and this gray color, okay, this brown color, you are having modulus x plus 1. Plus 1 means it will come under the first one, f of x plus c. Okay, f of x plus c. Plus 1 is inside the function. You should keep it in mind. If you are having plus c, it causes shift to the left. Okay, so you should compare red color and this brown color. Okay, red color and this brown color. Okay, so it causes shift to the left side. Okay, left side of this red color diagram. Are you able to understand this one? Yes. Okay, now we'll have the upward and downward direction. Okay, red color is the basic. So here f of x is modulus x, and here modulus x minus 1. So minus 1 is outside the function. F of x minus 1. So it will be what? This will be under fourth function. Y is equal to f of x minus d. So causes the shift to the downward. Okay, downward. So you just compare red and blue. So downward, the diagram will be shifting to the downward side. Okay, so by 1 unit, if you are having 0, it is -1. Here 1, it is 0. Here 2, it is 1. Okay, so in this way you can shift. And for the brown, no, modulus x plus 1. So it will be under third function, f of x plus d. So it causes the shift to the upward. Okay, to the upward. So in this way you can shift to the left or right or downward or upward. Okay, this is called as translation. Clear? Now the next type is dilation. So let us see what is dilation. It is a transformation which causes the curve stretches or compresses. Okay, so dilation will cause the curve to stretch or expand. Okay, other word for stretch is expand, or compress, contract, compressing. Okay, compressing the curve. Okay, you can stretch or compress in dilation. So let us see how to do this. Multiplying a function by a positive constant. Okay, so when you multiply a function by a positive constant, vertically stretches or compresses its graph. Okay, so when you multiply a positive constant, that word is very important. Okay, when you multiply a function by a positive constant, it vertically stretches or compresses its graph. This is not off, this is or. Okay, make note of this. Stretches or compresses. Okay, it is a typing error. Make note of this. If the positive constant is greater than 1, the graph moves away from the x-axis. See, I've changed all the colors. You should make note of this. This is all very important point. Okay, if the positive constant is greater than 1, okay, you are multiplying by a positive constant. No, if the positive constant is greater than 1, then the graph moves away from the x-axis. Okay, it moves away from the x-axis. You should talk only with respect to x-axis in dilation. Okay, in dilation. Next is, if the positive constant is less than 1, the graph moves towards the x-axis. Okay, so if it is greater than 1, the graph moves away from the x-axis. If it is less than 1, the graph moves towards the x-axis. And here you are multiplying only with the positive constant. You are not multiplying negative constant. Clear? Okay, so this is all about dilation. I'll just give you one example for dilation. Okay, so here, you know, red color is always the basic function, that is x square. Okay, and in the blue line you are multiplying 2 with this x square. Okay, so 2 into x square. So 2 is greater than 1. Okay, 2 is greater than 1. Okay, so the positive, when the positive constant is greater than 1, it moves away from the x-axis. So this blue line will move away from this x-axis. See, this is the x-axis, right? So it will move away. Away means what? Towards upward. Towards upward. Okay, and for this brown curve, it is 1 by 2 into x square. It is 1 by 2 into x square, and this 1 by 2 is less than 1. So when it is less than 1, it moves towards the x-axis. This red color graph will come towards the x-axis. Clear? Towards the x-axis. You got it? This is the main thing for dilation. Okay, so now we'll move on to the exercise problem. Okay, first question. For the curve y is equal to x cube, they have given the curve for y is equal to x cube. Okay, given in figure. Draw y is equal to minus x cube. Okay, so we have 4 subdivision. First we'll discuss the first subdivision. So y is equal to minus x cube. Okay, so given f of x is x cube. You have to write the given function as f of x. That means the base function is x cube, right? So f of x is equal to x cube. Okay, so in this first one, you are having y is equal to minus x cube. So y is equal to minus x cube. So this is f of x is x cube. So this is of the form minus f of x. Okay, minus f of x. So now you should go to the first type. This is of first type transformation. So you are multiplying with minus. So it is reflection. Reflection about the x-axis. I gave you three important keys. No, this is the first key. Okay. So if you are having y is equal to minus f of x, it is the reflection about the x-axis. Okay. So this red, always I denote the base function as red color. So x is the x cube base function, and this blue is the corresponding function. Y is equal to minus x cube minus f of x. See, reflection about the x-axis means this point will be under x-axis and this point will be under x-axis. This is 8 and this is minus 8. This is 1, this is minus 1. Okay, and what this is, if this is minus 1, and here you should mark it as 1, and I'm sorry, and this is minus 8 and this is 8. So this is the reflection about the x-axis. Clear? So in this way, without plotting the points, you can draw the diagram. Okay, so this is reflection about the x-axis. Now the second subdivision, you are having y is equal to x cube plus 1. Okay, so given f of x is equal to x cube, so in the second one is you are having y is equal to x cube plus 1. So this is f of x plus 1. Okay, so this will come under what? Translation. Translation, that means shifting left or right. So we need to check. For this you are having f of x plus 1. So causes the shift to the upward. By the definition of the translation, it causes the shift to the upward. Okay, so we'll draw the base curve, red color. It causes the shift to the upward by 1 unit. By 1 unit. If it is minus 8, it is minus 7, and here it is minus 1, and you should shift to 1. It is 0, you should shift to 1, and I'm sorry, and here you know it is 1 here, so you should mark to 2, and it is 8 here, you should mark to 9. Okay, so the shift is towards upward. Okay, upside. Okay, so in this way you can draw the curve without plotting the points. Are you able to understand? Yes. And then third subdivision. Third subdivision, you are having y is equal to x cube minus 3. So given f of x is equal to x cube, so y is equal to x cube minus 1. So this is f of x minus 1. So it causes the shift to the downward. So the curve will be like this. Red color is the base curve, and the shift is towards down. So if it is minus 8, downward minus 9. Here minus 1, downward minus 2. Here it is 0, here minus 1. It is 1, you should shift to the 0. And it is 8, here it is 7. Okay, downward. Okay, the shift will be downward. Okay, and the fourth subdivision, y is equal to x plus 1 the whole cube. Okay, so now let us see. F of x is equal to x cube. So here x plus 1 the whole cube. Okay, so it is f of x plus 1. Okay, so yeah, plus 1 is inside the function. Okay, inside the function. So if you put f of x plus 1, it is equal to what? X plus 1 the whole cube. Okay, so inside the function means causes shift to the left. Okay, shift to the left. So red is the base f of x, and the shift will be towards the left side. So if it is 1, it is 0. Okay, this one, and if it is 0, it is minus 1. If it is minus 1, it is minus 2. Okay, so in this way you can draw the diagram using transformation. The second question, for the curve given in figure, So what is the curve which is given in figure? So this is y is equal to x power 1 by 3. Okay, so this is the base curve. Okay, and you need to draw all the 4 subdivisions by using this base curve. Okay, so here y is equal to minus x power 1 by 3. So it is of the form what? Minus of f of x. Okay, so given is x power 1 by 3, so it is minus of f of x. So it is a reflection. Okay, reflection about the x-axis. Okay, the formula I gave you, the first one. Okay, you're having y is equal to minus f of x, so it is a reflection about the x-axis. Okay, so reflection means this point will be under, if it is 2, if it is minus 2, if it is 1, it is minus 1. Reflection about the x-axis. Okay, you should look at this x-axis as the mirror. Okay, mirror image. Okay, so if it is minus 2, it is 2. If it is minus 1, it is 1. Okay, so here I have plotted the points just to make it simple. Okay, simple to understand. Okay, so if you're drawing a curve like this, you just draw the rough curve. No need to plot the points. Clear? No need to plot the points. Excuse me, just you draw the curve. Okay, that is enough. Okay, so it is a reflection about the x-axis. Now the second subdivision, you are having y is equal to x power 1 by 3 plus 1. Okay, so here it is f of x plus 1. Okay, plus 1 is outside the function. Okay, so the shift will be towards upside. Okay, so it is f of x plus 1, so it will come under translation, so the shift will be towards upward. Okay, so by 1 unit, plus 1 by 1 unit. So minus 2 means minus 1. So it will be 1. By 1 unit you should draw the curve. Okay, you should keep it in mind and you should draw the curve. Okay, so in this way you can draw. Okay, and then third subdivision is y is equal to x power 1 by 3 minus 1, and here it is x power 1 by 3 minus 1. So it is f of x minus 1. Minus 1 is outside the function, so it causes the shift to the downward. Okay, downward. So downward, if it is minus 2, it is minus 3, here it is minus 1, it is minus 2, 0 means minus 1. So downward by 1 unit, downward by 1 unit. Okay, that is enough. See, again I am saying no need to plot the points. You just draw the given curve, and then you just draw the curve, exactly the identical curve towards the downside, towards the down. Okay, so in this way, and you can also just differentiate the given function, and this is the third subdivision. So you just differentiate in your own way. Okay, and then fourth subdivision, you are having y is equal to x plus 1 the whole power 1 by 3. Okay, here plus 1 is inside the function. Plus 1 is inside the function. So it causes shift to the left side. Okay, left side. So the curve will be shifting to the left side. Okay, left side. And here also again I wanted to say is, if you are having any doubt in this, okay, if you are having any doubt in this, in the rough column you may check whether your drawing, your diagram is correct or not. Okay, you can check by plotting the points. Okay, so in this way you can draw. The main thing is it causes the shift to the left side. Okay, so this is the fourth subdivision. Third question, graph the functions f of x is equal to x power 3 and g of x is equal to cubic root of x on the same coordinate plane. Find f composite g and graph it on the plane as well. Explain your results. Okay, so here I have just drawn f of x and g of x. First you draw f of x and g of x. For f of x, I have taken the points of x as minus 2, minus 1, 0, 1 and 2. And here you need to plot the points and you need to draw the diagram. Okay. So for the x value, you are taking minus 2, minus 1, 0, 1 and 2. Okay. This is for f of x and you get the value of y. Okay. And you plot the points. And for g of x, I have taken the values of x as minus 8, minus 1, 0, 1 and 8. Okay, so in this way you take the values of x and you get the values of y and you will get the figure like this. Okay, you will get the figure like this. And now you have to go find the composite of f and g. Okay, so f of x, g of x, which is given. So f composite g is f of g of x, and you just substitute g of x, that is cubic root of x. So f of cubic root of x is, by the definition of f of x, cubic root of x the whole cube. So which is nothing but x power 1 by 3 the whole power 3. So which will give you x. Okay. So if I make this f composite g as y, this equation is what? Y is equal to x. And for this also you need to plot the points. Okay. So give the values of x. So you will get y is equal to x like this. Okay. And you should explain this results. Okay. So this y is equal to x. Okay. It just divides the two function, okay, in two symmetrical way. Okay. So f of x and g of x. So f of x and g of x are symmetric about the line y is equal to x. Okay. You need to give your explanation like this. Okay. So f of x and g of x are symmetric about the line y is equal to x. So this is the solution for the third question. Okay. Now we'll go to the fourth one. Write the steps to obtain the graph of the function y is equal to 3 into x minus 1 the whole square plus 5 from the graph y is equal to x square. So you need to give some steps to obtain this graph. Okay, y is equal to 3 into x minus 1 the whole square plus 5. Okay, so let us see how to get all these steps. So consider y is equal to x square. Okay, so here x square, no, and in this function where you are having x square form, x squared form. So here you are having x minus 1 the whole square. Okay, so you should compare x square and x minus 1 the whole square first. Okay, whole square first. So here instead of x you are having what? X minus 1. Instead of x you are having x minus 1. So it is of the form f of x minus 1. So minus 1 is inside the function. Minus 1 is inside the function. So this cause the graph to shift to the right by 1 unit. By the definition of translation, you can get this one. Okay, causes the shift to the right by 1 unit. Therefore, see, x square means you can draw like this. Okay, for x square you can draw like this. X minus 1 the whole square means it will cause shift to the right by 1 unit. For 0 now you will get 1. For minus 1 you will get 1. For minus 2 you will get minus 1. Okay, to the right side. Okay, in this way you can draw. Okay, next is you got x minus 1 the whole square, right? So you finished x minus 1 the whole square. Next it is multiplied by 3. Okay, multiplied by 3. Therefore, it is a positive constant and which is greater than 1, and you should go for dilation. Okay, for dilation, this positive constant is greater than 1. Therefore, it moves away from the x-axis. Okay, since it is greater than 1, therefore it moves away from the x-axis. So now you are comparing this blue line, okay, which is x minus 1 the whole square, blue line. So away from the x-axis means what? It will go, it will compress, okay, it will compress, okay. So compress the graph, blue graph, okay. So you will get the graph like this, okay, away from the x-axis. And then next, so we finished 3x minus 1 the whole square, and one more term we are having plus 5. Okay, plus 5. So and now you compare this and this, and here this plus 5 is outside the function. Okay, when you compare this function and this function, this plus 5 is outside the function. So this implies it causes shift to the upward by 5 units. Okay, so now you need to compare this brown figure and this blue figure. Okay, so it causes the shift to the upward by 5 units. So here 1, 2, 3, 4, 5 means in between 4 and 6. Okay, so in this way you can draw the diagram. Okay, so you need to write the steps like this. Clear? Okay, next, fifth one. From the curve y is equal to sin x, graph the functions. So we have here also 4 subdivisions. So we are going to draw the graph. From the graph y is equal to sin x. So first
subdivision, y is equal to sine of minus x. So sine of minus x, by the formula it is minus sine x. Okay, so first we'll draw the curve for y is equal to sine x. Okay, you can draw the sine x like this. Okay, so from 0 you will start. For sine pi by 2 it is 1, sine pi is 0, sine 3 pi by 2 is minus 1, sine 2 pi is 0, and then sine for 3 pi by 4, I'm sorry, I don't know, after this 2 pi by 2 plus pi by 2, so you will get what, 5 pi by 2. Okay, so it is sine 5 pi by 2, it is 1. Okay, so in this way you will draw the curve like this. So this is y is equal to sine x, and the first subdivision is what, minus sine x. Okay, so minus of f of x. Okay, minus of f of x. So it is reflection of sine x about the x-axis. Reflection of sine x about the x-axis. So here, no, if you are having 1, you have to bring it to minus 1. Okay, minus 1. Okay, and here if you here you are having minus 1, you should bring it to 1 here. Okay, so in this way you should draw the curve. Okay, so it is reflection about the x-axis. Okay, so this is your first subdivision, and your second subdivision is what, y is equal to minus sine of minus x. So what you will get, sine of minus x is minus sine x. Already one minus is there, so it will be sine x. Okay, so second subdivision is nothing but y is equal to sine x. Okay, so the same as y is equal to sine x, you just simply draw sine x curve. Okay, this is for your second subdivision. And third subdivision is you are having sine of pi by 2 plus x. Okay, so pi by 2 is added inside the function. Okay, so y is equal to sine x. So inside the sine x function, okay, inside the function you are adding pi by 2. Okay, so you just draw y is equal to sine x. So it causes shift to the left by pi by 2. Okay, so if you go for the translation, you can check. Okay, so for adding the constant inside the function, it will cause the shift to the left. Okay, left by pi by 2. Left means what? You will get the curve like this. See here, no? For this 0, the point, you know, you should shift here. Okay, I'm sorry, you should shift here, and here you are having 1. I'm sorry, here you are having 1. You should shift to 0. Okay, so and here you are having 0 here. You should shift to pi. You should shift to pi by 2. So everything you should shift by pi by 2 to the left side. Okay, if you draw, you will get it. Okay, so this is for your third subdivision. And your fourth subdivision is you are having y is equal to sine pi by 2 minus x. Here you are having minus x. So you just take minus outside. So it will be what? Minus of sine x minus pi by 2. So that here, you know, you are subtracting the constant pi by 2 from this x. Okay, so it is of the form f of x minus c. Okay, so minus c is inside the curve. So and here you are having minus x, so you should compare. So y is equal to minus sine x. So for minus sine x, you draw like this. You have to compare like this. Causes the shift to the right by pi by 2. Okay, so if you are having x minus pi by 2, it causes the shift to the right by pi by 2. So from this you just shift. Okay. So in this way you can draw the diagram. Okay. The sixth question, from the curve y is equal to x, draw. So y is equal to x is given. You need to draw all these things. Okay. First subdivision, y is equal to minus x. Y is equal to minus x. So it is of the form minus of f of x. So it is reflection. So it is the reflection about x-axis. Okay. So this is the base. Y is equal to x. So if it is 1, it is minus 1. If it is 2, it is minus 2. If it is 3, it is minus 3. So reflection about the x-axis. Okay. And second is y is equal to 2x. 2x means you are multiplying the positive constant with x. Okay. And this positive constant is greater than 1. Okay. Greater than 1. So it moves away from x-axis. It moves away from x-axis. Therefore, so the diagram is like this. It moves away from x-axis. So therefore, what you will do, 0, 0 here. Now for 1 you will you will get 2, because 1 into 2 will give you 2, 2 into 2 will give you 4, so you have to mark it as 4, and 3 into 2 you will get 6, so you should mark it as 6, okay, in 6, okay, away from x-axis. And here also, minus 1 into 2 you will get minus 2, minus 2 into 2 you will get minus 4, and minus 3 into 2 you will get what, minus 6. So in this way you can first you draw y is equal to x easily, and then from this it moves away from the x-axis. Okay, next is you are having third subdivision. You are having y is equal to x plus 1. Okay, so f of x plus 1 is outside the function, so it causes the shift to the upward. It causes the shift to the upward by 1 unit, okay. So you just write by 1 unit. So here this is the base, and the curve that we need is towards the upward by 1 unit, okay. And then you are having 1 by 2 into x plus 1. So first we will do for 1 by 2, 1 by 2x. So 1 by 2x causes the graph to move towards the x-axis, because this positive constant is less than 1. Therefore the graph move towards the x-axis, okay, towards the x-axis. Okay, see, if you just see this. Now this red color is the base, okay, this red color is the base, and here you are having 2. So if you multiply this with 1 by 2, you will get what, 1. So you have to move towards, okay. And here you are having 4 by 2 is what, 2. So here 2, and it is 6 by 2 is 3, so here 3. So in this way you can draw the curve. Clear, move towards. And then 1 by 2 x plus 1, okay, so you're adding plus 1 with this function, okay, the brown line, you're adding plus 1, so it will cause the shift to the upward by 1 unit. So it will be what, and you should compare this brown brown and this blue, okay. So it moves to the upward direction by 1 unit, okay. In this way you can do this problem. And now we are going to the fifth subdivision. Given 2x is equal 2x plus y plus 3 equal to 0, and here y is equal to minus 2x minus 3, okay. So y and here first you should go for 2x, and then minus 2x, and then minus 3, okay. So if you're taking only 2x, you cannot take minus 2x, okay, minus 2x, because for reflection you will get what, minus f of x or f of minus x. In that way only you are having, that means you will add only with the minus, okay. But here you know you're multiplying only minus 2, okay. So for first you need to check for 2x, and then go for minus 2x, and then minus 3, okay. So if you put y is equal to 2x, it moves away from the x-axis, okay, because 2 is a positive constant, so it moves away from the x-axis. So and then minus 2x is the reflection of 2x above the x-axis, okay. Clear now? I think now you're clear. And then minus 2x minus 3 causes the shift to the downward, okay. From this you need to check, minus 3 causes the shift to the downward, okay. F of x minus 3 shift to the downward, okay. First red color is the base, okay, red color is the base. So this is y is equal to x, and then I didn't draw the line for 2x, okay. And this 2x is moves away from the graph, okay. And I want all the students to draw the graph of y is equal to 2x, okay. Y is equal to 2x. If you're having sketch, no, you just sketch it, okay. Yeah, I want every student to add this how the y is equal to 2x will look like, okay. So I'll just give you the way to do. So y is equal to 2x, no, so this is y is equal to x, so 1 into 2 will give you 2, Okay, 2 into 2 will give you 4. So I gave you the answer, just you draw that line. Okay, so the line will be in this form. The line will be in this form. Okay, the line will be in this form, and this brown is minus 2x, right? So it is the reflection of 2x about the x-axis, and it shifted to the downward. Okay, so in this way you can draw the diagram. Okay, and in the conclusion, everyone, you just draw the answer alone. Okay, you just put answer and you draw this line alone. Okay. And then seventh question, from the curve y is equal to modulus x. Here you are having modulus x. Draw first subdivision, modulus x minus 1 plus 1. We'll do the first subdivision. So here modulus x minus 1. So minus 1 is inside the function. So it causes shift to the right by 1 unit. Okay. And again plus 1. Plus 1 you are having causes shift to the upward by 1 unit. Okay. So red color is the base. Okay, red color is the base, and you cannot see because this blue line is there. So red color is the base, and this brown is nothing but modulus x minus 1. Okay, it causes shift to the right. Okay, shift to the right side of this base function. So right side by 1 unit. Okay, and then this blue is the resulting graph. Okay, upward by 1 unit. Okay, and you should draw the answer alone, blue color alone, in the answer section. Okay, so in this way you can draw. And the second subdivision, modulus x plus 1 minus 1. Okay, so x plus 1 causes the shift to the left by 1 unit, and this modulus x plus 1 minus 1 causes the shift to the downward by 1 unit. Okay. So first you draw a modulus x is red color. Okay, modulus x is red color, and then modulus x plus 1 causes the shift to the left. Okay, so left side you need to draw, and then downward by 1 unit. Okay, so in this way you can draw the graph. And then here y is equal to x plus 2 minus 3 modulus. So modulus x plus 2 causes the shift to the left by 2 units, and then this will cause the shift to the downward by 3 units. Okay, so red line is the base, and it causes the shift to the left by 2 units. So 2 points you need to shift, and then it causes shift to the downward by 3 units. So you will get the curve like this. Okay. And then fourth one, from the curve y is equal to sin x, draw y is equal to sine of modulus x. Okay, so we know that modulus x, for modulus x you will have x when x is greater than or equal to 0, minus x when x is less than 0. So similarly for sine of modulus x, okay, you will get sin x when x is greater than or equal to 0, sine of minus x when x is less than 0. Okay, so sine of modulus x is sin x, x is greater than or equal to 0, minus sin x when x is less than 0. Okay, so minus sin x is the reflection of sin x about the x-axis. Okay, and then the required curve is, first you draw the sin x. Okay, sin x is 0, and it will go to 1, 0, minus 1, 0, 1. Okay, and then for minus sin x, it is the reflection of sin x. Okay, so if you are having 1, and you should have minus 1. Okay, so in this way you draw the diagram. So this is the solution for the 8th question. So that's all. Thank you, students.